Okay, let us start the class. This is a very short class, a very simple kind of biometry. So, in the last classes, we have been primarily seeing behavioral biometrics. We saw keystroke dynamics. We saw voice or speech recognition systems. We also saw handwriting recognition systems, or so not handwriting, sorry, signature recognition systems. All these three are behavioral biometrics, which depend upon a person's behavior. And I have already told you that generally speaking, all physiological biometrics which are based on the human body, like fingerprint, face, retina, iris, are all hand recognition systems are better than the behavioral biometrics. The reason is behavior. Human behavior is erratic. All of us know that. We get angry, we get emotional, we get old. These things happen. It's natural process for all human beings to be erratic, angry, aging, and falling sick also. It's part of the game, right? So the reason, because of these reasons, all these behavioral biometrics like fingerprint, keystroke dynamics, signature, and voice or speech recognition systems go for a toss. And the FAR, that is the false accept rate, is high. FRR, false reject rate, is also generally very high. And we saw the hand and fingerprint recognition systems, which are better, but then all these five are not expensive. If you ask me, all these, whether it is hand and finger, which we saw among the physiological biometrics, and the speech recognition, or the handwrite signature, or the keystroke, all are not very expensive biometrics. But we want the best kind of biometrics, or we want multi-biometrics. We have seen in the initial classes that when we combine two biometrics, it is much more advantageous. Like, Aadhaar is using the iris and the fingerprint. But the fact of the matter remains that the best biometrics today we know are the retina scan systems and the iris scan systems, which are both part of the human eye. They have very low FAR, very low FRR. I would think that perhaps iris is a little better than retina, but more or less retina and iris are highly advantageous, highly efficient biometrics with very low FAR, false accept rate, and low FRR, false reject rate, which is what we also want. Now, what is the iris and what is the retina? The retina, if you see here, the retina, if you see here, there are some blood vessels here. These blood vessels are the retina. Whereas the iris is a muscular framework at the back of the eye. This is where the iris is there. It's a muscular framework. It's a pattern of or an appendage towards the back of the eye. So both are part of the eye. The retina is the blood vessel pattern in the front, not the front. I'm sorry, the back of the eye. This is the human eye. This is the human eye. This is the back of the human eye, and the back of the human eye we have this blood vessel pattern. Whereas the iris is like a diaphragm in the front of the eye between the pupil and the lens. It is between the pupil and the lens. You see here, the pupil is here, the lens is here, lens is here, pupil is here, right? And this retina is somewhere in between the lens and the pupil. Now, so both these are very good feature points, and both are very advantageous biometric. So the retina is a very thin layer of tissue with blood vessels on the back of the eye, 1 by 50 inches thick, and it transmits impulses to the optic nerve. Now, what it does is that the retina has thousands and thousands of rods and cones. Rods sense light, cones sense color, and the sensing of the light and the color is transmitted through the optic nerve to the brain, and that is how the brain comes to know that this is this is color, this is light. See, you see a red car, you know that it is a car. You need to see the car, that is the light part, and you need to understand that is of red color. That is done by the rods and the cones in the retina of the human eye, and these rods and cones transmit this light feature and the color feature to the optic nerve, and the optic nerve transmits it back to the brain, and the brain, you know, oh yeah, but this happens in a fraction of a millisecond. It happens not in 1 second, it happens in milli or micro or picosecond. In a flash you get that information. And what does the retina do? The retina is like a camera plus a digital signal processor. It does the job of a charge coupled device or a closed circuit camera. A CCD is a camera plus a digital signal processor. So that means the retina is the one that captures the image, captures the light, captures the color, and that signal is converted into information, and that signal goes to the brain, and you know that it is something. So that it does the job of a camera plus a digital signal processor. This is what I told you. There are lakhs of rods and cones in the eye. This is how the retina pattern looks like. You will see that there are red. This is nothing but the red blood vessels. Now, what happens? How you convert this into a biometric code? We will see that. Now, as I mentioned, retina is an excellent biometric. It's an old one. It's very information rich with over 400 features you can add to the feature vector, and with very high accuracy, 0.001 FAR. That means 1 in 10 million. Correct me if I am wrong. 1 in a million is the FAR. That means only 1 person in a million is likely to be accepted falsely. That's a great number, right? It's a very good number. And the reason is there are 400 plus feature points. Even the iris has a similar number of feature points, and so on. And the principle is that it identifies individuals by this retinal blood vessel pattern. See this blood vessels in the right. You will see this blood vessels moving here. This blood vessel pattern is what it looks at, and it is unique for each individual, including twins. Pattern do not change much over an individual's lifetime. The only exception is when a person has diabetes or diseases, macular degenerative diseases, which are somewhat similar, to diabetes, which because of that there is some emulsification of the eye and all. But again, that doesn't change much because there are 400 feature points. Even if you have diabetes and all, not so much of changes will be there. There will be some change, but not so much of change. Now, what happens exactly is that the subject looks into a camera at very close range for several seconds. An infrared power is directed at the pupil, and as a result of that infrared ray, you get an image which is captured by the camera. The captured camera image is nothing but like a blood vessel pattern, like this, right? It is a blood vessel pattern, and sometimes you need a high resolution image. You need to sometimes take several images of the retina, and that image you capture, and then what happens is that this image is you do a scanning, you do a cleaning, you do feature extraction of the blood vessels that are there in that pattern, and then generate a circular barcode based on that blood vessel pattern. So I'm again explaining the steps. First, you have an infrared camera. You ask the person to look into the close camera at the close range. Put an intensify a low power infrared device into the pupil. And the resultant image is something like that. It is an intensity profile. Then you do a scan, you clean up if necessary, you need to remove noise or cleaning up can be done. Locate the blood vessels in that pattern, convert those blood vessels into a circular barcode, and that circular barcode is is unique for every individual. As I mentioned, there are 400 plus feature points, and because of that, it is absolutely unique. Only exception is diabetes. Now, commercially, there are only 2 or 3 very good retinal scanners in the market. I think Identify is one, and they are very fast. Enrollment time is less than 1 minute. Verification happens in 1.5 seconds. Storage is also good, so but it's a little expensive. See the cost. Maybe the cost has slightly come down. This slide was maybe 2, 3, 4, 5 years old. Maybe the cost has come down, but again, for one device, even if you pay $1,000, it's very expensive, because if you are having a building, you may need to put 5 or 6 biometric scanners. That itself, if it comes to $5,000 to $10,000, it's very expensive. That is the main disadvantage of this retinal scan system, the cost, and only the cost. There is no other disadvantage. It's very good. It is accurate, very stable, it is resistant to fault, small template size. The 400 feature points are converted into a code. The code can be easily, circular barcode can be easily stored. Template is low, but if you are having diabetes, there is a problem. Weakness, cost. Cost is a problem. Customer perceptions of safety are there. Some people think it is intrusive. Actually, it is not intrusive. It's not touching your eye, right? It is only a camera. Then somebody will say radiation problem, and it's a little cumbersome to use. You have to go and put your eye in front of the IR camera. Otherwise, it is not able to. But having said that, there's no doubt about the fact that this is an excellent biometric, and the major disadvantage that we see here is the cost. We will see the same kind of pattern with respect to the. We will see the same kind of pattern with respect to the biometric, that is the iris recognition systems. So that's all from my side. I will close the class. You can stop the recording. Let me just take the attendance. Okay, before